basics. Good afternoon, friends. So today we are going to discuss the basics of the embedded systems. Because while we design the system, embedded system, six, and then only uh, we can design not embedded system, but an efficient embedded systems. So what we are going to see today is all about what is an efficient embedded system design. Okay. um, Remind me later. Okay. Before I actually start with the basics, I'll just cover few slides which I covered last time also. Mm, uh, okay. Uh, I can classify them from consumer electronics, appliances, automotive industry, and place of cell systems. Okay, place of cell systems. You must have heard of POS. POS, POS is place of cell system or point of sale also. People. So in consumer electronics, we have video players, appliances, we are well versed with the washing machines. Today we are going to see some examples also about the washing machine, how the embedded system gets designed. So, and what are the different constraints, considerations, design aspects, what are the different types of embedded systems. So that all we are going to have a insight in this today's lecture. So automotive industry, very well, it has been, these days you have been listening about microprocessor, fuel engine, MPFI kind of engines, and engine control, in order to have proper mixing of air and fuel. So these microprocessor fuel engines, ignition systems, they used to proudly display that this is microprocessor fuel injection systems. And earlier have been also air conditionings existing, but now what is happening is, mostly, see, ultimately what any ACs or anything is doing is, let's say heater also, what it does is actually, let's say talk about air conditioning. So it is actually cooling your space or cooling uh, your workspace, your house, or your um, any community hall or something like that. But now in the market, what happens is they are selling it all, selling these kind of products with different type of um, marketing strategies. And then when they are marketing it, what they say is there are different punchlines that our particular ACs with these kind of features. um, Many actor and actress are advertising these kind of things, and they say this happens, antibacterial, bacterial, many things are attached to it. So basically, who is the brain behind this? Who is doing this all controls? um, Microcontroller, or you can say embedded system inside it. So these days every device is coming with a brain. These are the smart devices, intelligent devices, what we can talk about. Day before I was listening to CEO of that Xiaomi company, Xiaomi mobile makers, Chinese make company, and they are almost going to overtake the Apple. And I mean, they are talking of that kind of ambitions that we will overcome, and we would like to become number one in the world, even ahead of the Apples and Samsungs. So what that CEO was talking about was, I mean, it's not that I haven't heard it before, but what he said was the mobile he launched, it was costing less than Apple phones. But what he said was the future will belong to, like, whoever will buy our mobile will be able to get connected to all the devices, all the whatever devices he is using in his day-to-day life. So it is whether it is his home, whether it is his office, whether it is his car, everything will happen through that. So that's what he was talking about, and he says that that kind of scenario we are talking about, internet of the things, so they will get ported on the kind of thing there. So you may please help me connect in there. So that is what, so therefore the point is, like, I'm making that everything is getting intelligent, smart these days, and therefore all the products, they have basic functionality, but that is not enough. You need to be smart. So that is what every product company, manufacturing company, is doing these days. And then how it happens, the design engineers make it possible. The brain behind it is actually design engineers, embedded system design engineers, embedded system engineers. So what they should be essentially aware about is they should be knowing that what are the rule of the game. So what are the basics of the game? What are the efficient system design considerations of the smart system design? Because we will see in the due course of this lecture that you'll uh, mm, let me check this. In the due course of this, that there are a lot of design considerations, there are a lot of type of different, no, yeah, yes, this is not it, this is not this is not it. You should open it there, you will find it. So so that is what this today's lecture is all about. So we have been seeing this. Why is that? So let us talk about all these. So these are the applications, and in various applications, various design considerations, they matter, because finally you will also see in the design considerations of the embedded system that it's not only about the processor, what is the size of the processor being used, but it is also all about the application. Like when you will check, because I'll come to that slide also, what are the factors shaping of the performance of the system, that is uh, performance of the processor that you want to and plan to use it. So it will not only about the what is the size of the processor that you are using, what is the architecture of it, but it also will matter about the application. So therefore these applications matter. So computer peripherals, so there are different applications in measurement equipment. These are all embedded systems, but they have different constants, design constants, and uh, various factors. So in measurement equipment, normally, in measurement equipment, see, normally what you require is actually ADC conversions. So any 8-bit controller would do that job. Other day I was discussing with one of my student who is doing thesis with me, and he's from VIT Vellore. Uh, it's in Tamil Nadu, I guess. So he was discussing, and there are different students working on different problems. So initially, that person is working on some particular electrical impedance spectroscopy based some water quality parameter estimations, and he was earlier talking of some other technique like anodic stripping voltammetry or cyclic voltammetry. And initially when we talked about cyclic voltammetry or analog stripping voltammetry based technique of water contaminant measurement, we almost zeroed down the use of the 8-bit controller. And it was essentially, I would say, because you will see that it will belong to the small scale. There are different classification of the embedded system: small, medium, and complex, sophisticated, which becomes more complex. Even then you don't find the development tools in that case. So we almost decided that we are going for 8-bit. That means small range, small family, small embedded system family category. And later on it emerged out to be going to be a DSP based kind of scenario, because then we realized that if I integrate the another technique of electrical impedance spectroscopy, wherein a lot of sine wave correlation fitting techniques and algorithms are going to be embedded and ported on the thing, on the chip. So really, no, it is in my, it opens. I did that already earlier. Oh, please go in your cabin then and get it from there. So then it all ultimately emerged. I'm sorry for all the interruptions. What is happening is actually my original presentation, which I made little more improved and added some more details for your benefit, is not actually opening up. And what I made few years back is there, but almost this industry, it has not changed much, and the basics remains basics. But still, I have much more better details for you. I think she's getting it from another place. It is there on my email, so she will get it downloaded, and so I think you will get benefited. Don't have to worry about it. So so I was talking about my experience with one of my student, and I was just trying to inform you that it ultimately emerged out to be a like we will go for the DSP based processors because of that all computational intensive requirements. So therefore the point was like the application will matter, right? Therefore initially I'm just trying to show you different applications which you can see over here, and uh, these are the different controllers, different versions, because in embedded systems the brain of the system is processor or microcontroller. And this slide is slightly, maybe it is not in the proper flow, but just for the sake of information you can understand it. Are you able to see this? Okay, you can see it there and they are seeing it there. Okay, I am also getting familiar with this thing, and so you can see that the first device is 8051 having a 4 kilobyte of ROM, because while we design the embedded system, you'll get to know, because there is complete flow also, like we design the specifications of the applications and then we finally come down to the selection of the components, and that is how the complete flow, overall flow diagram is also included in the PPT which she will get. Meanwhile, we will see the other details which I have. So here is the complete table. So while you actually initially work out with your actual requirement, the next step goes is actually buying the right processor, right controller for your application, because that is the brain of your embedded system. So how do you do that? Because most of the controller sorry, manufacturers, they have selection tables available on their websites. So one of the table you can see here is the 8051 controllers produced by Intel, and you can see that there is a 8051 series which is having 4 kilobytes of ROM, 128 that RAM which you are aware of, and you can see that timer, counters, to and interrupt sources and frequency, because it will also matter how should be the speed of your. Be aware of all the devices listed over here, but I had a chance to work with most of them, and older, so I have been working from last 14 years, so I got that chance and I was privileged. So that first is not having that much of memory, and later on you can say 87C51. 87C51, have you heard of that? Okay, just but this there are few things here which even I also don't know, telling you frankly. But 8751, you see 8051 is having no window on that, right? So it is having the masked memory inside it, whereas 8751 is having the windowed version. So there is internally embedded memory in that which can be erased. But now we have 89 series, and the specialty of 89 series. I talked it in my lectures, earlier lectures also. It has got flash. 89 stands for flash. Okay. Okay. Anyway, so let us go to the next, and this is a block diagram, because you know very well there is a control unit. Okay. So this is all about the architecture, and you're aware of this. This has been covered already. Actually, I don't have to get into this, because there is difference between processor and microcontroller that you're aware of. What is the difference? Yeah, microprocessor itself is not a complete computer. Microcontroller is a computer on a chip. Okay, and I'm sure that your other teacher is much better than me in that, in telling you the basics of the 8051, because they are all finally professors and we are researchers. So well, now we have also started teaching in our, because we have opened new academy, and I have been doing that job for last 2-3 years in the same subject, embedded system. So this main difference is actually it lacks the ports, which is essential requirement for developing any real world application. So that is what is actually included when the same design team engineer who developed the processor also developed the microcontrollers. So they felt the need and they included whatever was missing. Okay. So I don't have to put you much questions on that, and better I should focus on introducing you to more and more information. You know why computer is useful? And you know there is no single answer to most of the questions in this world. There is no silver bullet which is a solution to all the problems. So here is also the same case, that computer is useful because it can execute the programs. Okay, and programs are known as, you know, software. When we write a lot of programs, and then it becomes software. And program is a set of instructions. These are very basic things, and it is stored in the memory in the form of binary number called machine instruction. So I think we are well versed that it is in the binary and this machine language, and then that is why we need the compilers and interpreters and assemblers which converts that language, and finally machine works on 1010 things, right? That's difficult because this binary is difficult and not productive. So therefore that was the importance of the uh, computer. And then came the embedded systems. What is that? What is so special about embedded system? I discussed, but I would like to ask, what is so special about embedded system? Yes, wonderful. And I think the results are always good when the person gets focused, so dedicated. So if you miss dedicated word in your definition of the embedded system, it is not embedded system. If you just simply say combination of software and hardware, no, I would give 0 marks straight, because simple as that, because it is the major thing, the key thing which actually differentiates the embedded system from the general purpose processors, your computer, PC. So dedicated is a very important keyword there. Now let us see what are the characteristics of the embedded system. It is single function. Again, that is what it means, the dedicated thing. It has complex algorithm, but okay, user interface tightly constrained, because whenever there are constraints, like we have power constraints, we have cost constraints, we have space constraints, we have memory constraints. So these are the constraints. When you talk about the embedded system, there are constraints like memory, cost, power, speed also. You cannot think of any high speed, and I'll show you in the slides. I think probably she has got it, that there is a trade-off, and if you try to build a very high speed power thing, then your power or your cost, these are getting, you know, disturbed. So there is a complete rule box for that, how these factors change, and then how ultimately it affects the overall influences the overall design. So there are characteristics of the embedded systems. Yes, that is so nice. Thank you very much. Yeah. Uh, so reactive and real time. Embedded systems are real time, you know, real time systems, RTS systems. You know what are the types of RTS systems? What is real time first? What is real time system? Just tell me. I know you guys are very intelligent. I'm very fortunate that I'm encountering a very talented, you know, crowd over here. I'm not joking. I'm very serious. That guy, you know, almost answers everything, sitting over there. You know difference between ordinary and extraordinary. All right, because this class is not all about that, discussing that ordinary, extraordinary, but otherwise philosophically there are wonderful definitions and examples, and they are very encouraging and motivating. Um, and finally, you know, this life is all about motivating others. If you can motivate, this life is all about motivating what? Others. Do you agree with me? Please say no. At least because I want to tell something. You know, why don't you say that, why I'm saying this life is all about motivating others, and why not motivating self? The answer is simple, because I know you will also tell many answers, but what I have, let me tell you that, because today you are listening me. Uh, see, I will give you what I have. So if I am motivating you, that means what? You got the answer? That means motivation is already inside me. I don't have to motivate myself. So this life is all about motivating others. So this life is all about making others happy. That means it is there already in me. Anyways, so let us talk about the real-time systems. And I am asking, it means that I know. So let me know, what is real-time system? Which is not the case with the computers, right? Yes, from audience from the remote end connected through ICT. ICT is such a wonderful thing. I'm really enjoying with that, and I was really, mm, you know, very happy to see, because I was listening these lectures also, and I was watching this audience also, the recorded thing, and it really makes a wonderful thing, wonderful experience. Yes, audience over there, what do you know real time systems? Yeah, CGC Landra. Yes, yes. So there is a designated name also. CGC Landra. I know you are the number one private college. Yes, I'm sure you'll agree with my knowledge on that. That you are number one. Even if they are not there, they're not saying to no, going to say no. Yes. Are you able to hear me at least? Give me acknowledgement.
So
At least you are.
are you
Yes.
asking about real-time systems?
Yeah. Can you please just tell what is the real-time system?
So please pardon.
Yeah. What is real-time system? What do you understand by real-time system?
The real-time systems are in which the time constraints are fixed. There should not be any delays there. Actually, the process has to be completed at that correct point of time. For example, signaling in railways or temperature controllers in nuclear systems.
Yeah. Good. Good. Wonderful. Wonderful. Thank you very much for simplifying my job, because you have answered most of the things, and in fact, I was not aware of this. So thank you very much once again. And these real-time systems, because they will react in real time without wasting the time. And as long as you are, if you employ these characteristics in you also, you will be always leading and prosperous in your life, and you'll not be suffering and you'll not be having misery in your life if you keep yourself in time. Everything, you have to be in time. You don't have to miss the bus. So you have to be real time in the real world also. So real time systems, they don't miss. There are constraints with the time. Okay, they have to operate and execute within the constraint of the time. It has to be done within that particular time only. So but there are two types of real time system, my dear, who the one who answered me. There are two types of real time systems. I don't know if you are aware or not, but I'll not let you answer that, because I know the answer, so I'll tell you the answer. So there are two types of real time systems: hard and soft. Now I'll put you questions, because I don't know what is hard and soft. There are two types of system, real time system. There is hard real time system and there is soft real time system. But okay, I'll not wait for the answer, because if I go on questioning like that and keep on waiting, I think we'll not finish this lecture today. So you know the keyword, I'll tell you the keyword. Okay, and it is always good practice in life to remember the key things, keyword. So I'll give you the keyword here for discriminating these two types of system, real-time systems, and the keyword is catastrophic. So this catastrophic, that means it is not severe. I mean very severe, severe or not severe. The effect becomes very severe or not severe. So catastrophic. So catastrophic is a keyword. In hard real-time system, if that system is not acting in time, the effect and results are catastrophic, very disastrous. Okay, something like you know let's say talk about the missile. Missile is coming. If there is not real-time intercept, you know what happens, right? So that is one of the example in strategic sector. Similarly, in the case of healthcare, there are healthcare devices which doctors use. If some device is meant for supplying oxygen or something like that, and if it is not okay, responding and reacting in real time, then it's a question of death, life, right? So wherever there is a question of life and death, so it is real time, hard real time system, hard RTS. And when it is not question of life and death, it is not, it is soft, okay. But both are having a constant to work, to execute and respond and react within a time, in a constant of the time. So that is the difference between these two systems. And specific areas under embedded system design. Embedded system is a very vast thing, very vast thing. Microcontroller, microprocessor based design, RTS, multi-processing systems. You have more than one controller, distributed network, more intelligence, network intelligence, embedded software architecture, devices and drivers like modem is there, and this, drivers are written for small pen drives also. Even this mouse independently is an embedded system example. So devices and drivers are written, FPGA based system, accelerated IC design, RTOS. Even there are ICs, there is, let's say there is a requirement to generate a square wave pulse or sine wave, some waveform generator, or a phase detector. So there are ICs specifically, and who does this operation? There is a one example, DDS, direct digital synthesis. Those ICs, they have complete architecture, and inside that, to control the complete architecture, there is again a brain. So that is itself is a embedded system. And RTOS, of course. Uh, Now let us talk about the classification of embedded systems. Okay, mainly that depends upon the complexity. Okay, so based on the complexity, we can uh, differentiate and classify the uh, embedded systems. So there are three types of embedded systems. One is small, okay, small scale embedded systems, SSES. Okay, and let's see what is that. I think simple to understand. If there is single 8 or 16-bit microcontroller, it can be 8-bit or it can be 16-bit, but it is a single. And the hardware and software is not that complex. A simple instrumentation example or anything like that, which uses the 8-bit or 16-bit controller, and there is not much hardware. Let's say you are using some temperature sensor IC and you're just monitoring it on LCD. Simple. So it becomes small scale SSES. Board level design, battery operated. Normally most of the ES are battery operated. And the restraints here are, again, because you cannot go beyond really uh, some uh, some limitations. For example, memory. Okay, so in case of memory, let's say I cannot go beyond 64K or 32K or 128K. So when there are restraints like that, so memory restraint or power dissipation, then these are all the characteristics of the small scale ES. And skills required normally while you design small scale embedded system, probably this applies to all of you since you are beginners. So skills required would be, you'll have to get familiarity with the computer architecture, microcontroller, software designing, you should be knowing detail electronics, because sometimes you need to design some logic, 0 and 1, and or this nor. So these things are required somewhere to design particular control signals, because you have chip select, output enable, this kind of scenario comes while you design the real world. Yes, data communication, control engineering is required. Data communication, maybe sometimes if you are into robotics, the control engineering plays a lot of role. uh, and these days everything becomes wireless, so, and otherwise also wired also, you need to have some communication protocol like you have serial, parallel, okay, that sort of. So then motor, actuator, sensors, that sort of skills are required. You should be knowing that what is motor, how it works. Even if you don't know, I mean, Knowing means what? You may be arts or commerce person, right? You may be any student, not necessarily for must be from the engineering. You may be anything, but in order to design the small cell ES, you got to read all this. Even if you don't know, you'll have to know it. Without knowing these, you cannot, because in small scale ES normally a lot of applications would come which will require that some sort of knowledge amongst all of this. So that is the requirement. Then comes your medium scale. So as the name signifies, it is self-explanatory that there will be little higher level. So like instead of 8 to 16, now the bar is 16 to 32 bit. So that sort of a migration will be there from so far as the processor family is concerned. And then you might be aware of the architectures, RISC and CISC architecture. Have you heard of this? But I'll tell you on that also a little bit. And it may involve or may not RTOS. Then little bit of this distributed encryption distribution can fall into this. Real-time scheduling algorithm can also be used, because once you have higher level of family, these all possibilities RTOS exists. Then in sophisticated embedded system, the processor multi-processor systems are there, like quad, octa-core, quad-core, and in safety critical applications where the safety is of utmost importance, like your nuclear reactors and nuclear plants, you have this kind of safety requirements. So there the systems are very complex and they need to have high-end controllers. Um, so like that. And then hardware software co-design. You know that uh, what happens is like many parameters, like there will be co-design. It's not necessarily that everything need to be solved with the hardware only. Many things can be solved with the software also as well. So that is hardware software co-designing. So you'll have to go with the concept of co-designing. Wherever whatever is more optimized, you go for that approach. It can be either software, it can be hardware. Now see, here are the next step is actually what are the components. What are the components of embedded systems? It can be like essentially there is going to be your brain. That is the central part of it. Heart of the system is brain. Here, that is CPU, different processor selections. Some slides will come on that also. Which processor should be going for? What are the criteria? But otherwise, in general, you would come across this kind of I/O peripheral devices, and they would include ADC, DAC, because in real world mostly things are analog. So you will have to either externally or internally go for the ADC, and sometimes maybe you have to generate some excitation signal. So you would need DAC, because DAC gives you the analog signal. You will have to provide it somewhere else. Maybe it is a stimulus to something, or it is acting as a timing pulse somewhere. There will be some another circuitry also, like to convert it to into square wave and all, something like that. So you would require DAC as well. Sometimes you are driving a motor, so you would again require DAC kind of scenario. You would require some kind of constant current source designing. There, these kind of things, they play a role of input signal. So most of the times people desire that things should happen on the chip itself. There is no need for the external things. So, but otherwise, I mean, whether they are inbuilt or externally available, these are the blocks, building blocks. Basically, these are the building blocks. ADC, DAC. There can be sensors also. In fact, these days, whatever it is, embedded system, I would say it is incomplete without sensors. Even if you take example of your this thing, mobiles. So a lot of sensors are coming in this. Can you name? Yes, yes. That is eh? Microphone. Okay. More. Hmm? Yes. Yes, when we change the direction in, it changes. What is that? उसको क्या बोलते हैं? And huh? Gyrometer. I was waiting for that. What for do we use the gyrometer? Yeah, it is actually gyrometer, not gravity. So gyrometer is the right word. So that is what they are coming up with, and this touch one, this is a fringing field effect. So this capacitive touch screen is again uses the sensing principle, capacity sensing principle or resistive sensing principles. A lot of sensors are coming everywhere. So in fact, most of the things without sensors, nothing exists. GPS receiver, okay, it is a GPS receiver, but it is a sensor. It senses the position, okay. So sensor is very important. So it is not all about the instrumentation only, because when we talk about sensor, people think, okay, sensing is actually measurement. Of course, it is sensing, and normally then people consider, okay, instrumentation, because I'm thinking that way because I'm coming from a central scientific instruments organization. So it is mostly dealing with the instrumentation, and there is wherever there is instrumentation, sensing comes mostly. So we have sensor systems things. So it's not all that, but normally everywhere sensors are there, whether it is smart house, whether it is your air conditioning, most of the places. So whatever is the process and process control, quality control, everywhere there are sensors. So therefore, the point I'm making is here is actually in real world applications, when you build your embedded systems, there are building blocks, and which includes all these sensors also. So you would come across the FPGA or ASIC based design. So don't think that embedded system is only microcontroller. Okay, don't get into that misunderstanding. So embedded system can be with FPGA, embedded system can be with DSP also. Okay, the basic thing remains dedicated. Okay, that is the main thing. Memory, okay, you will require either it is, forget about whether inbuilt or outbuilt, external. Memory is going to be there. Wherever you will require more memory, you can go for the higher. Can you guess what will be the maximum memory available so far in embedded systems? About computers, I know you guys will immediately tell me that it is 1 terabyte TB, and these kind of hard disks are available. The hard disk I am carrying is 1 TB hard disk, very smart, compact one. How about the embedded system? Because the embedded system is having, it is one of the important constraint. So while you design your application, you should be knowing how much is available in the market. Uh, it has concept of speed also, power also, memory also. So it is not available to you in abundance. That don't think you can design anything. So you have these constraints. Constraints are limitations. It's not abundance. You have to define. There is a constraint which actually applies the restraint. So 128 GB तक मेरे ख्याल से है. I guess. I think so. 128 GB, because in recently I am upgrading my platforms, and we were using 32 GB earlier. What that soil conductivity, this soil for precision farming soil mapper, that embed application which we discussed the other day, we were using earlier 32 GB, and now we are trying to migrate to the 128 GB. And in fact, I asked my student to explore the possibilities of connecting the compact flash, which can go up to 1 TB also. Those cameras. Cameras are also the example of embedded system. A very good example, in fact. So those cameras have these all inbuilt. So it can go very compact flash memories are, there are different types of memories. So CF they can go up to 1 TB also. So actuators also will be required. Can you guess any example where you would require actuator? No, he was right. He was telling something, but he got shy. Yes, that is the best example. Robotics. While I designed my that liquid dispensing system, most of you have heard of that real world application of ES. There we use a lot of actuators, electrical actuators, pneumatic actuators. So there are different types of actuators, basically. So actuators will be also required. So in fact, the definition of embedded system is all about, embedded system is a processing thing. There is a sensor, so inputs are coming from the sensors or otherwise, and then embedded system, your that computer, that CPU processes the things and comes out with a decision or some action, and it takes action. So that is actuator. That is how we represent the embedded system: sensing and actuating. So these are the blocks, building blocks. Then human machine interface, you know that already. Human machine interface is all about you have that interaction between the human and the machines. So that is one of the important key component of the embedded system. There are diagnostic ports. Can you tell something on that? Diagnostic port? Have you heard of diagnostic port? I have changed the terminology a little bit here, and then you would agree with me that when I will tell you another keyword, that you'll say yes, yes, we know that. No, you are using, तुम ज़्यादा लगा रहे हो brain. So please preserve it for some useful purpose. कभी है ना, तो अगर तुम डायग्नोस्टिक पोर्ट इसी को थोड़ा सा सोचने की कोशिश करो, द वर्ड इटसेल्फ, हैव यू हर्ड ऑफ debugging? Debugging. Now you will say I know that. So diagnosis is all about, so when you debug something, so there are ports like, have you heard of JTAG? Joint Test Action Group. That JTAG is a Joint Test Action Group. The short name of that is JTAG. Joint Test Action Group developed one protocol, boundary scan and all that. So they designed a protocol for debugging. So that is a port, kind of port. Okay. So whenever you have in-circuit debugging simulations, so there are protocols. Without that, you cannot go with. So, and then you have, obviously, the upper portion is representing you hardware, and the bottom portion is representing the software. And this is actually the combination of hardware and software when it is meant for a dedicated application. So it becomes an embedded system. So here is the list. Okay. These includes the processors, timers, counters, power supplies, reset circuits, and then your oscillator circuits, application specific circuits, so memories. These are all the interrupt controllers without which you cannot design any embedded system. So when we talk of hardware, these are all the items which you have to deal with and you have to be familiar with. So these are the hardware items, hardware building blocks when we talk of embedded system. And when it is software, there are only two things. And in fact, in this world, embedded system things, in this world, I would again take a philosophical viewpoint that even human being is an embedded system. We are meant for some dedicated tasks, and we have some journey to complete, and all these body parts are actually hardware, and what is stored here is a software, and it is doing something. And when you get dedicated and focused, actually it is embedded system. So let us be an efficient embedded system in life too. So let us talk of software. And therefore, if you don't select the right hardware and right software, then disaster happens, then accident happens. So look at this software: application specific software, series of tasks, constraints, available memory. The software is actually application specific, right? Isn't it? So, and this software, it is a series of tasks which it will perform. Let us talk about the elevator, lift. It has a series of tasks to perform: stop, go, okay, up, down, something. Many things are like that. Speed also, it changes. When it sees that person is going on first floor, speed will not that matter. Going 50 floor, speed will increase. So that intelligence has come into the elevators and lifts also. So therefore, a series of tasks are there. Then you have constraints. In software also you have constraints. You have to understand available memory, available processing, power dissipation limits. Because if you go on writing the codes which are consuming a lot of memory, not done. Okay. So therefore these are the constraints, and then you have RTOS. So in software there are two things. When we talk of embedded system, two things: either you would write a simple application specific software which is just sensing the temperature, or it would be sensing position or something like that. It would be simple affair, or it would be complex affair. When it becomes complex thing, it will belong to definitely higher end of the family of the embedded system, that is sophisticated family, and then you will have RTOS. So the missiles and those satellite things which they design in ISRO, so they will require that kind of sophistication. And in RTOS, then a lot of things are there. Basically, you have to allocate the resources, because then there is a lot of optimization in terms of various factors, context switching, like what happens in that interrupts. Something comes, interrupt comes. This is what we do in our life also. Something comes, interrupt comes, we leave what we have been doing. We go and attend the things. We attend the guest who is knocking at the door. He comes, we are finishing that, again going back to the task. Push pop. That is what we do in life also. So that is context switching. That terminology is called as context switching. So therefore, any system will have application layer. Any embedded system will have application layer, or it will have RTOS. I mean, sorry, not or. Any complete ES will have application layer, RTOS, and hardware. Now I will explain to you in a more simplified way. What is application layer? I'll take an example of this mobile. The GUI, what you are interacting with, is actually application layer, where the user interacts. User is providing all the inputs on the GUI. So your actual interface, the user's interface, is with the GUI. And then there is RTOS. Behind that, what is working is whatever you are actually pressing, it actually responds. When you press something, it attends to that. It is also receiving the call. So if you are playing something or marketing something here, is it the case that it is not able to receive the call? If somebody is calling, it also is receiving the call. So that is RTOS. So there is a RTOS layer in that. And then there is if you just do the things on the top layer, that is application layer, GUI, and let's say RTOS is also there, working at the background layer, second layer of the thing, embedded system. And if there is no hardware, things don't work, because what you press here, what you say here, let's say call. You are saying call. I'll tell you now how. You will say call. Now unless that call, what you have said on the application layer, activates the soft hardware in it, उसमें जो रिसीवर है, ट्रांसमीटर है, मॉड्यूलेशन है, डीमॉड्यूलेशन है, जीएसएम है, ये सब कुछ जो टेक्नोलॉजिकल एस्पेक्ट्स है उसके अंदर वो सब ऑन ऑफ नहीं हो रहा है, ट्रांजिस्टर 1010 का डांस नहीं कर रहे हैं, तो वो वहां पर कनेक्ट नहीं होगा. ठीक है. सो वो इस तरह से आपको हार्डवेयर भी चाहिए. So therefore, that is how your complete embedded system is. ESD2. This is almost same, but I have something more on that to tell you. The processor in system. Okay. So there is something called as program flow control unit, which controls the program. There is program counter. You know that it goes to next. It points to the next address, and there is an instruction to be executed. And there is an execution unit. It goes, fetches, decodes, executes. Processor का यही काम है ना? There is a program flow control and execution. So there are two units, which is controlling the program execution, and there is second is which is executing it. And for execution, of course, it is using all the resources like RAM, register A, register B, वो जो अपने temporary registers होते हैं, उस टाइप के सभी चीजें वो यूज करता है resources को. But basically there are two units. Now what are the types of the processor? General purpose processor, that is microprocessor. Because if you use microprocessor and if you connect the things are externally and design the thing for a dedicated task, will you not call it embedded system? So you can use this thing also. So in microprocessor family, there are general purpose processors, GPP. And then see, this is how the journey is. The Motorola started with the 68 family. Intels का जब नाम लेते तो 80 family से शुरू होता है. फिर आर्किटेक्चर वाइज वो अलग चीज है. बट स्ट्रीम 3 जो है उसमें स्पार्क सन वालों ने लॉन्च किया था, स्पार्क वाला फैमिली. स्ट्रीम 4 पावर पीसी, एक आईबीएम का एक पावर पीसी काफी हिट हुआ था बीच में, काफी पावरफुल माना जाता था, बट वो चला गया थोड़ा बीच में. बट आई थिंक दे हैव लॉन्च न्यू फैमिली आल्सो व्हिच इज डूइंग गुड जॉब. And then, what shapes up the performance of your embedded system is also has something to do with your architectures. So here is the RISC and CISC. Do you know the story of RISC and CISC? See, any processor has two things to it: hardware and software. So hardware, US government gave the to two universities. You know that. Harvard, Van Neumann और Princeton भी उसका नाम था. So there were two chief leaders, project investigators working hard and Van Neumann. So हार्वर्ड में उस चीफ investigator ने डिजाइन किया कि देयर सिंगल बस विल एक्सेस, रैम रोम सिंगल है उसमें, देयर इज सिंगल बस एक्सेस करने की, डेटा बस जो है एड्रेस बस और डेटा बस तो एक ही बस से काम होगा. एंड प्रिंसटन वालों ने जो वैन न्यूमैन ने किया, देयर विल बी बस रैम के लिए सेपरेट. ठीक है. So they found that later on, initially they found they thought that speed would be good. We are not talking about sales, but I'm telling you the hardware architecture first. That since there is a access time, less time, and it is going only to one place, so it will be easy. But then they discovered that parallel is always better. Parallel is better speed. So two, एक ही रास्ते से गाड़ी आ रही, so there is traffic. Then you have two separate roads. Let's talk about risk and safety. But something, something is trying to. Should I continue? Yes. So let us talk about this story, because as I said, the performance of any controller or processor, which is the brain and the factor shaping up the performance of embedded system, is concerned. Then there are two things: hardware architecture and software architecture. So software-wise, there is a RISC and CISC. The story started like initially they had a philosophy like, because and many factors were responsible. It's not that they were foolish or they were less talented at that time when they designed CISC architecture. You know what is CISC? Complex instruction set computers. So the philosophy was that since the memories were not that advanced, so what they thought that processors were powerful, I mean compared relatively. So they believed that I would give analogy that in a house, let's say somebody is, some person is powerful amongst the sibling. Let's say one is little better in terms of energy or brain, whatever you call, but the person is stronger. So normally even parents would expect or take a wisdom that okay, you handle more, you are big. That is how it happens. Even you have your small sibling, parents, and they would say that you are big so you can handle better, so you need to share more. So you are big, you are better, so you share more. So you are more powerful, you share more. So that was the philosophy in case of CISC architecture. That what they said was processors were powerful. So what they said that we will design the complex instruction sets. So CPU will handle the instructions, will take the load, and will not bother the memory, which is a weaker sibling, and therefore the access time is reduced, because speed is all about how
Uh, so we can't get you the audio right now. EDV Studio, so we are unable to hear. Hello, hello, ETV Studio. We are unable to hear your voice, sir. Can you please fix it? Sir, we are not able to hear you. The voice is not coming. Please, can you fix it? Hello, ETV1, can you hear me? Hello,
Hello.
ETV1, can you hear me? Sir, we are
Yes,
not getting. Sir, we are not getting the voice. We are. Hello.
yes. Hello,
Hello.
hello.
Sir, is this is ETV one?
Yes, sir.
Sir, we are unable to get your voice, sir.
एक मिनट. Okay. Hello. हाँ जी. Okay, 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 okay.
Hello.
ਗਗਨ ਸਰ ਸਾਊਂਡ ਨਹੀਂ ਆ ਰਹੀ ਪਲੀਜ਼. ਹਾਂ ਉਹਨਾਂ ਦੇ ਉੱਤੇ ਪ੍ਰੋਬਲਮ. ਪਲੀਜ਼ ਸਾਨੂੰ ਬੁਲਾ ਲਓ ਮਾੜਾ ਜਿਹਾ. ਕਹਿੰਦੇ ਗੱਲ ਕਰ ਲੈਣਾ ਇਹਨਾਂ ਨਾਲ. ਇਹਨਾਂ ਨੂੰ ਨਹੀਂ ਨਹੀਂ ਹੈ. ਆਡੀਓ ਫਰੋਮ ਅਦਰਸ. ਉਹਨਾਂ ਦਾ ਦਿੱਤਾ ਹੈ.
ਇਹ ਦੂਜੇ ਸੈਂਟਰ ਤੋਂ ਆਇਆ ਨਾ, ਦੂਜੇ ਸੈਂਟਰ ਤੋਂ.
ਸਰ ਉਹਨਾਂ ਦੀ ਆਡੀਓ ਨਹੀਂ ਆ ਰਹੀ. ਆਡੀਓ ਨਹੀਂ ਆ ਰਹੀ ਉਹਨਾਂ ਦੀ ਆਪਣੇ ਕੋਲ. ਆਡੀਓ ਨਹੀਂ ਆ ਰਹੀ ਉਹਨਾਂ ਦੀ. ਹਾਂਜੀ ਕਰ ਲਿਆ ਸਰ, ਫਿਰ ਵੀ ਨਹੀਂ ਚੱਲ ਰਿਹਾ. ਉਹਨਾਂ ਦੇ ਉੱਥੇ ਪ੍ਰੋਬਲਮ ਆ ਗਈ. ਠੀਕ ਹੈ ਜੀ, ਠੀਕ ਹੈ.
ਨਹੀਂ ਮੈਨੂੰ ਉਹਨਾਂ ਦੀ ਜਦੋਂ ਨਹੀਂ ਆਉਣਾ
ਜਦੇ ਇਹ ਆਇਆ ਜਦੇ ਨੂੰ.
पाजी ऑडियो आ रही? 10 to 10.
आंसर करो, आंसर करो.
हेलो. Center 10. Are you listening me?
यस
नो नो सर
बाकी क्या ऑडियो आ रही है ईटीवी 1 से? आपके सेंटर पे क्या ऑडियो आ रही है?
नो सर
एक मिनट
ओके, थैंक यू भाई.
ਉਹਨਾਂ ਦੀ ਆਡੀਓ ਨਹੀਂ ਆ ਰਹੀ ਉਧਰੋਂ ਏਟੀਵੀ ਬੰਦ ਹੋ ਗਈ ਜਨਰੇਟਰ ਦੀ ਬੰਦ ਹੋ ਗਈ ਬਾਕੀ ਸੈਂਟਰ ਦਾ ਚੱਲ ਰਿਹਾ ਸਾਰਾ
Yes, ready?
ਸਰ ਲਿਖ ਦੋ
Yes, you are ready. You may take the message. She will probably talk on that only.
चले जाना
Yes, are we ready? Okay. So, fewest voltage is one of the consideration that we should make, and conserve the power by small masses. That on-off thing you can. That is a software thing, and obviously, I mean, you can select the with ice or in a man they consume less. So it's consideration. You can see that the because for the same functionality like switching matrix, same switching can can consume less power or high power. But for example, your application requirement to matter. More detailed consideration you will make. For example, in case of switching, let's say I know that my switching can be at a little lesser speed also. Speed will not matter that, so there don't have kind of switching matrix which is at a very high speed, ultra speed. We go for that, then obviously it consume more power. Speed has direct linkage with that. It is the speed, it will consume more power. So therefore, conserve the power of our choices. So similar number of considerations in case of hardware. Again, you are shut down when not needed, so you can shut down your hardware. So most of the hardware, your chips these days are coming out with a sleep mode, okay, idle mode. They have different names, but you can make up from the they are using and the keywords they are using that this can lead for saving on the time. And in fact, sometimes it happens that most of the ICs is they have inbuilt talent. If they are not in use, they'll go to the sleep mode. So mostly I think I have seen it in well, it is not an system, but I have seen it in the Dell companies. They go to sleep mode, and I think now subsequently it has been copied by most of the computer manufacturers. So that is what all about. They are not in use, they should go into the idle mode, sleep mode, but provided they should wake up. So, and then availability. So availability matters a lot. Since it happens that you will see that in the technical availability will play a lot of role, because your if the time of launching it gets delayed, your development cycle gets delayed because of availability non-availability issues, it results into suffering your revenues. The product which you are designing is actually will suffer your revenues. If I draw on y-axis the revenue, is the time. Okay, so therefore availability will matter. Temperature stability and calibration. Obviously, if it is having deviations, performance is deviating because of the temperature and all that, your embedded system is going to be something else. So they are very critical considerations, but that is what will make a difference between you as an efficient engineer and other who is not. So and I think probably that is what is making a difference between Apple and some other brand. They are taking very full considerations for everything. Develop to the eventual form. What is that? You were there last time too? But you forgot. Never mind, because I also forget. Every human being, it is a common characteristic between us. Amongst us, we have common characteristics. We always, RAM. As soon as we battery, gone. And battery is actually revision. It updates. So refreshes. That refreshing is always required. So develop to the eventual form is actually, if you are developing anything, let's say, even it is a mobile or microwave oven, whatever it is. So if you want the final form to be this, and you are saying that I am doing R&D and I am firstly ensuring the functionality and designing the things, but in that stage you are developing something like that big, and eventually you wanted that, okay, what you are designing, you're designing a wristwatch is form this much bigger size, and wristwatch is to be placed here. So you can imagine what happens. So develop to eventual one, because finally then again you will have to cut down the things to this, and then it always then has, you have to pay the cost for that. Nothing comes free. So develop to the eventual form. That is the design consideration. It's not that you will say that my hardware first I will ensure functionality. It is not the case. It doesn't work. And fuse boards, obviously reliability has all things to do, whether it is reliability, power, cost. If you are using fuse boards and make a smart choice, you don't have more number of boards, so your choice, your reliability will be better, your cost will be less, your system will be smart, your failures are going to be less. If you have more number of boards connected, then your debugging, your maintenance. The other day I was seeing latest design, I think from Microsoft probably. They're launching the modular mobile, what they call modular mobile or portable mobile. Modular mobile is all about, every part can be removed. Sorry, every part can be removed. Whole mobile you can remove everything out of it, and they have reason for that. What they say is that your maintenance is easy. Okay, so fuse boards, software considerations. So obviously, by now we have understood that embedded system is combination of soft and hard thing. So software wise, you should write something which is easy to understand, because let's say in a development cycle, normally in team it happens that somebody is going and new player is coming. It is happening in Big Boss. You know that. So whether it is serial or whether it is hardware. So okay, so software wise also you have to write something that it is easy to understand. That is something called as readability. So easy to understand, so that next person comes and takes over easily. And functions, I think you know that, because most of you have gone through this experience of writing the C codes. And what is the best practice is writing number of functions. Instead of writing a single, write more number of functions. It becomes more portable and modular approach it is. What is necessary precision? Necessary precision is actually, again, it has something to do with the over designing and under designing. You need, let's say, millimeter scale here, something, I mean, very crude example or whatever, millimeter scale. Why do you want to design micro gauge? If you can measure, your requirement is millimeter, why should you go for micrometer? I mean, it's not that you are crazy or going mad about it, but if you have extra money, or I mean, you can over design the things like what our engineers do while they build the bridges here in our country. Where we need the 4 laning, they do 2 laning of the roads. You know that? And where we actually need 4 laning, they will do 2 laning. Where the bridge is required, there is no bridge. And where bridge is not required, there is a bridge. So necessary precision. You have to ensure that there is a necessary precision. Okay. Otherwise, your system, what you are designing is not an efficient embedded system, and it will lead to the extra cost, extra power, all extra will happen then. You are becoming extra smart, so you'll have to bear the charges, bear the cost of it. And best thing is, that there are two types of interrupts. There are two types of systems which can be designed: real-time system, vector polling and interrupt. So interrupt is always more efficient. Okay, because it is hardware based. Whenever something is hardware based, it is more efficient. And in vector polling, it is software based. Like you design your flow chart, then you say this happens, that go to that, and sometimes bugs also comes. But when it is hardware, you know that interrupt is there on interrupt 0 pin or 1 pin, all thing happened, or in ADC some signal has come, immediately the interrupts are coming and then they are following the particular. It happens because something like when you're calling somebody, maybe he's not picking the call, but when you go actually in person, then he has to face you. So it is hardware approach. Okay, so and hardware wise the systems are very efficient. So real-time interrupt and multitasking, you should inculcate that multitasking in software. Types of digital IO peripheral we have already covered. Hmm? To switch to that, and almost we have finished all I some where and when we different blocks, the system also so has got battery dial. There are parts all should move only every second. There are rules. The hardware parts are there is a motor, there is okay. What this way we will contracting based or and using switches and whether it is a hot water, cold water, or making connections, you need these all uh, I have to do many times this kind of offers. So I am aware of this. And for these type of operations, you have to do rinsing also, washing also, and drying also. And so it makes and so there have a also. That is what so and then based on that you have to actuate the walls also for opening and closing with hot water or close. Once it drains the level, it closes. So rules of washing machine, you will have spinning action, rinsing and drying. All these operations. These are the rules, and accordingly you will have and there will be interruption. Like whenever there will be interruption, it will save that status, and it will next time when you switch on, it will complete the remaining tasks. Therefore, एम्बेडेड सिस्टम का डेफिनेशन एंड सॉफ्टवेयर वी एम्बेड इनटू ROM. You know, embedded system also is operating system. You know that, and we save that operating system to ROM. What we write a firmware is an operating system. So when you switch on your mobile, something is happening at boot up time. It is a booting time, but it is fast. Okay, and let me also give you some interesting information. The mobile phones these days, not call it embedded system, you know, because it is becoming a general purpose. You can play game, you can play, it becomes your tab, you can write the word and you can do the PowerPoint. It is not embedded system anymore. It has become general purpose machine now. So whenever it is missing the dedicated thing, it is not an embedded system. But normally we consider mobiles embedded system as long as it is not a general purpose. So okay, so there is software that we write into ROM, and it doesn't need any secondary memory. Okay, as is the case in the computers, like there is a cache memory and this memory. So there is a program, and this program, there is a hardware, that is a chip, and this program is burnt into the hardware. That is embedded system. Say interest was only to sensitize you with the basics. Otherwise, there are many things. डिजिटल सिग्नल प्रोसेसर में क्या होता है, एप्लीकेशन ये वाले प्रोसेसर में क्या होता है, मूर्स लॉ मैडम ने आपको बता दिया, एवरी 2 years डबल हो जाता है, 2015 तक रहेगा, ट्रांजिस्टर डेंसिटी वगैरह, हार्डवेयर वगैरह. सो हार्डवेयर वाइज हमने देखा, सॉफ्टवेयर वाइज हमने देखा. सॉफ्टवेयर वाइज आपको सॉफ्टवेयर है, कंपाइलर है, सिमुलेटर है, 3 चीज़ों से आपको डील करना पड़ सकता है व्हेन यू टॉक ऑफ एम्बेडेड सिस्टम. और हर एक में जो है, हर एक में स्पेशलाइजेशन की जा सकती है, PhD की जा सकती है. ठीक है, एवरीथिंग इज वेरी वास्ट. और एप्लीकेशंस में ये सब आप देख रहे हो. और एक कैमरे का एग्जांपल मैं जो बता रहा था कि है, वो भी इट्स इज वेरी गुड एग्जांपल. इसमें सब कुछ एम्बेडेड सिस्टम का ही है, जिसमें कि सिंगल फंक्शन, टाइटली कंस्ट्रेंट, रिएक्टिव एंड रियल टाइम. डिजाइन चैलेंजेस में आपको देखो ये सब चैलेंजेस आएंगे, जिसमें वो कॉमन मैट्रिक्स बोलते हैं इसको, जिसमें आपको यूनिट कॉस्ट, नॉन रिकरिंग कॉस्ट, साइज, परफॉर्मेंस, पावर, फ्लेक्सिबिलिटी, ये सब डिजाइन चैलेंजेस का इसको बोलते हैं कॉमन मैट्रिक्स. और जो मैं मैट्रिक्स की बात कर रहा था ना, पावर इधर बढ़ेगा तो परफॉर्मेंस ऐसे होगा, तो परफॉर्मेंस ऐसे होगा, तो साइज को क्या होगा, NRE को क्या होगा. सो दिस इज दैट मैट्रिक्स, डिजाइन मैट्रिक्स, जिसमें डिजाइन मैट्रिक्स कंपटीशन, इंप्रूविंग वन मे विल वर्सन अदर्स. अगर परफॉर्मेंस को करोगे तो साइज में गड़बड़ हो जाएगा और बल्कि हो जाएगा. प्रोसेसिंग पावर बढ़ाओगे तो, पावर को करोगे तो उधर कॉस्ट को कुछ होगा, कॉस्ट भी बढ़ेगा. सो दिस इज तो दोनों की आपको एक्सपर्टाइज होनी चाहिए, हार्डवेयर सॉफ्टवेयर की, अगर आपको ऑप्टिमाइज करना है. ये एग्जांपल में बताया था आपको कि टाइम आपका बढ़ेगा, टाइम टू मार्केट, डिमांडिंग डिजाइन मैट्रिक्स. अगर टाइम बढ़ेगा राइट साइड में एक्स एक्सिस पे, तो आपका उधर रेवेन्यू जो है कम हो जाएगा. ठीक है, सो दिस इज अ डिजाइन मैट्रिक्स. एंड लॉसेस देखो, जितना आप ऑन टाइम एंट्री करोगे तो लॉसेस कम है, एंड इफ योर डिलेड एंट्री है तो आपका रेवेन्यू घट रहा है. सो दिस टू ट्राइंगल्स आर शोइंग यू दैट थिंग. सो आपको ट्रेड ऑफ करना है चीजों का. एंड इसका एक फिर फार्मूला है, कैलकुलेशंस के भी है. तो डिजाइन इंजीनियर जो करेगा ना एम्बेडेड सिस्टम, ये सब कैलकुलेशंस करता है वो अपना, जब पूरा डेवलपमेंट साइकिल बनाता है कि कितने वीक्स लग रहे हैं, और उसके हिसाब से रेवेन्यू कैलकुलेट करेगा, मेन आवर्स कैलकुलेट करेगा. मेजर कंपोनेंट, आरटॉस, ये सब कुछ हमने देख लिया. हार्डवेयर देख लिया, कंपोनेंट देख लिए, क्लासिफिकेशंस देख ली, मीडियम. As I was saying that because the presentation I used was 2 years before made, but the basics remain same. That is what this new presentation is also covering. और ट्रेडिशनल डिजाइन फ्लो जो है, आपको स्पेसिफिकेशन फाइनल करोगे, मॉडलिंग करोगे, सिस्टम मॉडल होगा, सिलेक्ट करोगे आर्किटेक्चर का, हार्डवेयर एंड सॉफ्टवेयर इम्प्लीमेंटेशन करोगे, प्रोटोटाइप तैयार करोगे, टेस्टिंग करोगे, ओके करोगे, फैब्रिकेशन करोगे. गड़बड़ है तो टेस्टिंग से वापस जाएगा वो, फिर से इनफॉर्मल स्पेसिफिकेशन से फिर वापस जाएगा, मॉडलिंग में फिर से वापस जाएगा. तो ये डिजाइन फ्लो है. और मॉडलिंग में आप देखो, एम्बेडेड सिस्टम की मॉडलिंग करते हो तो आई विल नॉट एक्सप्लेन बिकॉज वी आर ऑलरेडी ओवर विद द टाइम. डेटा फ्लो ग्राफ, फाइनाइट स्केल, फाइनाइट स्टेट मशीन और पेट्री नेट्स, ये 3 टाइप के एम्बेड सिस्टम मॉडलिंग है। और हर एक मॉडल यहाँ पर मतलब डिटेल्स था मेरे पास बताने के लिए आपको। जैसे ये एग्जांपल है डेटा फ्लो का, ग्राफ का, कंस्ट्रक्शन का, मॉडलिंग का। तो ये सब जो है आपको कर सकते हो आप। फाइनाइट स्टेट मशीन में भी ऐसा ही कुछ एग्जांपल है कि डिपेंडिंग अपॉन क्या स्टेट है, आप अलग अलग स्टेट्स को, कि उसने S1 अगर इनपुट स्टेट S1 का अगर 1 है तो वो S1 पे रहेगा, और S2 अगर 0 पे है तो S1 पे रहेगा। और अगर उसका स्टेट अगर S2 का 1 है और S1 का 0 है तो S2 पे रहेगा। तो ये डिजाइन स्टेट्स का पूरा मॉडलिंग के है, फाइनाइट स्टेट ट्रांजिशन टेबल। जैसे एग्जांपल है लॉक का, लॉक और अनलॉक कर सकते हैं। सिमिलरली आप सीट, जैसे आपने देखा होगा कि हम कार में बैठते हैं तो क्या होता है कि वो सीट लगाओ तो बजर बजता है, बेल्ट लगाओ तो बजर नहीं बजेगा, और बेल्ट नहीं लगाओगे तो बजर बजेगा। तो उसमें जो है ये डिजाइन स्टेट मशीन एग्जांपल उसमें दिया हुआ है कि आपका देखो सीटेड है तो, और सीटेड है और बेल्टेड है तो बजर ऑफ हो जाएगा, और अगर आप सीटेड हो और बेल्टेड नहीं हो तो बजर को ऑन कर देगा। तो डिफरेंट ये फाइनाइट स्टेट मशीन के एग्जांपल थे। पेट्रीनेट एक अनदर एग्जांपल है, उसमें ये पूरा स्ट्रक्चर है, कैसे कैसे स्टेट्स में जाता है वो। ये हम कभी और किसी और लेक्चर में कवर करेंगे बाद में। सो जैसे एग्जांपल वेंडिंग मशीन का है ना। वेंडिंग मशीन में आप, ये एग्जांपल है एक फाइनाइट स्टेट मशीन का। वेंडिंग मशीन में आप जैसे एम्बेड सिस्टम, इट इज एन एम्बेड सिस्टम, राइट? यू एग्री विद मी? सैचुरेट हो गए क्या? यू गॉट सैचुरेटेड? सो इसमें जैसे आप डालोगे सेंट, सी मतलब सेंट है, तो ये 0 सेंट है। 0 सेंट से अब देखो, सॉरी 0 सेंट है, क्या हो गया, सॉरी दैट इज नॉट फंक्शनिंग। अदरवाइज ये पूरा स्टेट जो है ना अलग अलग स्टेट्स में जाता है। सो एनीवेज ये देखो वेंडिंग मशीन का। सो आपने 5 सेंट दिया तो देखो 5 सेंट के बाद 5 सेंट तक गया वो डिपॉजिट, फिर आपने उसने फिर से 5 सेंट डाला तो 10 सेंट हो गया। 10 सेंट के बाद में फिर से डिपॉजिट किया 5 सेंट, 15 सेंट हुआ। तो 15 सेंट के बाद में फिर से आपने 5 सेंट डिपॉजिट किया तो 20 सेंट हो गया। तो वो देखो 20 सेंट के पास चला गया। सो यू विल गेट योर वॉट एवर यू वॉन्ट, 20 सेंट का वो 20 सेंट का आएगा। और दूसरा उसमें अगर आप 15 सेंट वाला एक केस है बार, तो 10 सेंट डाले आपने, 10 सेंट हो गया, उसके बाद में आपने डिपॉजिट किया फिर से 5 सेंट, इट बिकम्स